God aften means good evening in Danish. So good evening to you. This is Mr. Begeiski. Today's lesson is 4.3, the right angle theorem. This theorem is a theorem that can replace going from perpendicular to right angle to all right angles are congruent, but definitely has to be used to prove if two angles are congruent, then you can call two lines to be perpendicular. So the theorem that we're going to address today is right here. The theorem says if two angles are both supplementary and congruent, they are right angles. Well, hopefully that logically makes sense to you, because if we draw two angles, the two angles next to each other have to be supplementary. So those two angles are supplementary, and they're congruent, so they have to be the same number. Okay, then they would have to be right angles. Well, sure, because the only number that you could get to equal 180 that would still be congruent would be 90 and 90, which means that they're right angles, which causes those two lines to be perpendicular. So really, the idea that we're saying, that we used to have was M and M were perpendicular. So then we could say angle 1 and angle 2 were right angles. And then we're able to say that they are congruent because all right angles are congruent. When def of perpendicular and all right angles congruent. So this theorem now is going to develop, throughout. So let's just jump into example 1. So our goal is to get that AB is perpendicular to CD. Obviously ending with this new theorem here. So our goal is, if we're trying to get that AB is perpendicular to CD, ultimately, if we can get these angles right here, any of these angles here congruent, then we know that they will be perpendicular, because if they're right, if we can make them right angles, then we cause two lines to be perpendicular. Our givens: C is the center of the circle. So from C, red flag goes up, right? Center of circle, we have CA is congruent to CB. Those two would be marked congruent. And then we got circle D. So once again, we're thinking red flag, where are the radii to do it? So we look at it, and it should be kind of obvious where these lines need to go in, and we did it 2 days ago for homework, where you have to draw something in. So this is obvious. This is kind of like finding where's Waldo. It's one of those pictures. Where is Waldo? So obvious, right? So obvious where Waldo is. He's right there. Don't you see him? He's right there. So obviously just draw the lines in. AD, DD, mark them congruent. As of right now, this is where we're trying to look and say, okay, what two triangles can we draw a conclusion that are going to be congruent? CA is only in this triangle, so we only have one thing marked. DA is only in this triangle. But wait a second, if I use that CD is reflexive here, I can prove the top triangle, CAD, and the bottom triangle, CBD, congruent to each other. So that's where we want to start. So we're going to start with C is the center of the circle, causing CA be congruent to CB. We also have to draw in, so we're going to have to draw in AD and BD, and then from there we could say that AD is congruent to BD. You with me so far? Good. Up to reason 3, we have the reflexive CD congruent to CD, which now we're up to reason 4, triangle CAD congruent to triangle CBD. Now we need to take a step back. Our goal, like we said, was to prove that these two angles are going to be congruent to each other, so we could use our new theorem up here to say that two lines are going to be perpendicular. Well, as of right now, it doesn't matter what you take, but I'm kind of trying to hint towards you what to take. So look at the picture. What else did I mark that we haven't used yet? Ta-da! 1 and 2 are congruent. Have you found Waldo yet? So we're going to go to angle 1 congruent to angle 2 because of CPCTC, which now helps us prove the triangle. Let me highlight them in a different color. Triangle CAE and CBE congruent because the sides are marked, the angles are marked, and once again, this piece is now reflexive. So we got the angle. We'll bring back CA is congruent to CB, and I'll put that 1 in front of it because we got it from there. And then the reflexive piece was 3 again, but that's CE now. It's congruent to CE. Bracket this together, reason 6. We just proved triangle CAE congruent to triangle CBE. Obviously, CPCTC is going to come next. Now what do we need to take? What did I say? We wanted to take these two. So we're going to take angle CEA congruent to angle CEB. Oop, wall goes up, ran out of room. Last reason, reason 7, we can now prove AB is perpendicular to CD. Ta-da! We're done. Give us the reasons. 1, all radii congruent. 2, 2 points make a line. 3, reflexive. 4, side, side, side. 5, CPCTC. 7, sorry, 6. 6 comes before 7. 6 is side, angle side. Once again, CPCTC after that, but we put a 5 there. And 7, the newest one, what is it? Up here, angles are both sup and congruent. Then they're going to be the perpendicular. So what do we have? We have if 2 angles sup and congruent, then perpendicular, just like we read. All right? Hopefully that makes sense to you. Good luck to you on the next one. What kind of proof was this, by the way? I heard you say it. Detour. Detour. Just like we've been doing in Unit 4.1. All right, let's wrap it up. Last one here. So note, the median to the base of an isosceles triangle is also an altitude to the base. Okay, so we've done this. This was just on the last chapter test, and always, sometimes, never. You have to know that if you're in the isosceles triangle and you have a line going from the vertex to the base, and it's called a median, it's also an altitude, it's also an angle bisector. Okay, so this proof is going to prove that. So we're going to mark our picture up. AB is congruent to BC. BD is a median. Median causes what? Midpoint. Midpoint causes two things to be congruent. And then, ooh, I see a reflexive side here. So we're going to be able to prove these two. So what do we have? We're going to be able to prove these two triangles, ABD and CBD, by side, side, side. Side, side, side. Yes, sir. So let's do that. I always like to start with the more challenging one. So we got BD is a median. Underline it because it's given. Reason 1, we could say D is a midpoint of AC, which causes AD to be congruent to DC. Next, we have the other given, AB is congruent to BC. And lastly, we have, looks like reason 3, reflexive BD congruent to BD. Causing triangles ABD to be congruent to triangles CBD. All right, let's take a break here. All right, welcome back. So what do we have? We have BD is an altitude. So that's what we're trying to prove. Altitude causes perpendicular. Perpendiculars come from the right angles. So what do? We know CPCTC comes next, so that's a 5. What do? Oh, we haven't used 1 and 2 yet. Look at that. 1 and 2 are going to be congruent to each other. There's your CPCTC step. We know they're supplementary, so that means using our new rule, BD is going to be perpendicular to AC, which then if we finish up here, BD is an altitude. Good stuff. Let's go through it. Reason 1, we have definition of median. 2, then the definition of midpoint. 3, reflexive. 4, side, side, side. 5, CPCTC. 6 is our new rule. If 2 angles sup and congruent, then perpendicular. And 7, definition of altitude. Hopefully you understood this lesson and this makes sense to you. We're going to be using this rule, and we're going to be ending with things with perpendicular. So we're going to force you to use this rule, but you don't have to necessarily, if you start with perpendicular, use this rule. But if you're going to end with something to make it perpendicular, you're going to have to use the new rule. If 2 angles subcongruent, then perpendicular. And did you find where Waldo is? If you did, there he is. Good night.